Hello, and welcome to BIM 200, the BIM Execution Plan, Executive Summary. This video discusses how Building Information Modeling, or BIM, will be managed on specific projects through approval and use of the BIM Execution Plan. BIM is an evolving technology, and the methods for its deployment and implementation continue to improve. The BIM Project Execution Plan, or PXP, is developed by the design and construction team at the beginning of a project. It allows the entire team to understand their roles and responsibilities and to plan their work process. This reduces the overall risk to the project because processes and deadlines are synchronized at the beginning of the project, as are the resources necessary for the effort. It is a way to measure progress throughout the project. The government reviews the PXP when it is first developed and then uses the PXP to monitor BIM activities during the design and construction phase. The government consults the approved plan to validate compliance, conduct reviews, and verify that deliverables are submitted in a complete and timely fashion. The project team uses the accepted plan to synchronize the effective BIM tools to successfully achieve the project goals. MHS is one of many government agencies that require new projects to be developed with BIM technology. BIM is widely used by architects, engineers, and construction contractors because it allows each organization to work more efficiently, both individually and collectively. MHS has outlined BIM objectives and developed BIM requirements. The BIM requirements include the descriptions of the building data MHS needs to manage, operate, and maintain the building. The government uses the PXP to verify that this data is contained in the BIM model and is in the correct format for MHS needs. BIM is known for its value in achieving enhanced visualization through 3D representations of building components, but it also has great value as a repository or tool for coordination of data. The benefits of enhanced visualization are easy to appreciate. It can take years of training to understand a two-dimensional drawing of a complex HVAC system, but the 3D model is easy to understand from day one. Enhanced visualization permits more effective communication, troubleshooting, and understanding of system components and their relationship by all stakeholders. The benefits of BIM as a data repository have great application. BIM objects, like the ductwork shown here, have associated property tables as part of the native software. Additional property tables can be created by BIM users. The property tables allow the attributes of the ducts to be linked to the model and exported to other applications, eliminating the need to manually retrieve information from specs or manufacturer's literature. In the BIM process, information generated by one group can be easily retrieved, evaluated, or used by another group. Programming information developed by MHS can be read into the model as it develops, allowing designers to understand and validate the program for design. Also, SEPS components can be automatically generated from the program and located in the correct rooms. As the project proceeds, design data transferred to the builder. Information developed during construction, such as manufacturer's specifications, is ultimately provided to the owner-operator for their operations and maintenance personnel. The MHS BIM minimum requirements serve as a guide for required BIM submittals that must be included in the PXP. These submittals include schedules, reports, and verification of model compliance with MHS requirements and are required to be in technology formats that are well known and accessible to the design and construction agents, such as Excel spreadsheets. One useful way to leverage BIM technology is to more quickly and accurately validate the program for design, or PFD. The BIM model can export information about the type and size of rooms in the model that can be compared to the PFD to validate that requirements are satisfied. The government will verify this by reviewing the exported report, typically via a spreadsheet. Similarly, SEPS data can be absorbed by the BIM model to convert medical equipment to BIM objects and verify that the equipment is placed in the correct room. The government can verify this by reviewing PDF files exported from the BIM model. MHS does not intend the PXP or BIM process to be disruptive or difficult. BIM allows the project delivery team, consisting of the MHS, design and construction agents, and associated project contractors for design and construction, to work smarter, not harder. The Government Performance and Results Act requires agencies to improve performance and manage data more effectively. BIM is a useful tool for achieving these goals. Rather than trying to manage many documents developed independently by multiple consultants, BIM is an integrated model that reflects the accumulated contributions of the project team. The data submittals and reports itemized by the MHS BIM minimum requirements are, for the most part, requirements that have existed for over 15 years. The use of BIM allows the data to be retrieved more readily and analysis to be conducted more quickly and thoroughly. The MHS has prepared the training video, BIM 200 Extended, the BIM Execution Plan, to provide detailed information for the government to effectively monitor BIM Execution Plan compliance. Most importantly, the MHS understands that the adoption of new tools can cause confusion. We encourage government personnel to reach out to ask questions about BIM execution on their particular projects. We hope this video helps explain the value of BIM and the BIM Execution Plan. For additional information, please visit the MHS World Class Facilities website at the link shown on this slide.